Today we're going to talk about some concepts involved in using different bases. First, we need to just introduce the points. Each column represents a larger piece. This is the unit. It's one little square. In base 7, which we're going to start off working with today, the long will have 7 little individual unit squares joined together, and the flat will have 7 longs joined together to make a flat. Therefore, as soon as I get 7 little units in here, I have to trade them in for a long. Therefore, I can never have more than 6 in this column, because as soon as I get 7, I have to trade it in. Same thing is true here. As long as I've got 6, I'm okay, but as soon as I get the 7th one, I have to take all of them and trade it in for the flat, which goes in the next column. All right, let's start off by just illustrating some numbers. The first one we're going to do is 2, 4, 6. That little 7 subscript means it's in base 7. So we don't want to read it 246, because that is how we would read it in base 10. So we just want to say the numbers 2, 4, 6, base 7. That means that there are 2 things in the flat column. It means that there are 4 things in the longs column. And it means that there are 6 things in the units column. Basically, all it's telling me is how many to put in each spot. Let's copy 2 more here. All right. So these numeration pieces illustrate what 2, 4, 6 base 7 means. Okay? Now, we're going to talk about what it equals in a minute, but we'll come back to that. So ignore that little equal sign for a minute. We're just going to illustrate one more in base 7, one that is not in its lowest or most efficient form, and that would be 3, 7, 8 base 7. It has 2 problems. The longs and the unit columns are a problem because they have more than 6 in them. But let's go ahead and illustrate it as it is for a minute. So that means I need to have 3 in my flats. I need to have 7 in my longs. And it means that I need to have 8 in my units. Okay. But we can't have that in base 7. The most that we can have in any one column is 6. Once I get to 7, I have to trade it in. So let's do that. Let's take 7 here, trade them in, and move it over to this column. Now I've got too many here. I have to trade in 7 of those. That's not going to work there, though. Right? And we'll move it over here. Okay? So 3, 7, 8 in base 7 simplified becomes, I traded in 7 of these, so I actually have 1 left. Got 1 more, so I had 8, now I've got 2 left. So it really, in its simplified form, is 4 flats, whoops, 1 long. Made a mistake. and 1 unit. So that's how you would simplify something in a different base, in any base. These same principles apply to base 10, which is our numeration system, or to any other numeration system. Okay, let's look real quick, just so we can have a practice with another base, at base 6. Okay, same concept. The little square is the unit, the strip is the log, the bigger square is the flat. But notice the difference here. The unit does not change. It's always going to represent just one individual piece. But in base 6, my log is now composed of 6 units hooked together, as opposed to 7. So what do you think would be the most we could have here? We would have, the most we could have here in base 6 would be 5, because as soon as we get to 6, we have to trade it in for a strip with 6. Same thing here. If we can have 5 and be okay, when we get 6, we trade it in for the bigger piece. All right, so illustrating 1, 3, 4 would be there's 3. Let's just make this quicker. And there's 4. So there's 1, 3, 4 in base 6. The concepts don't change with the base. What changes is how many can be in each column before you exceed the maximum possible number there. So that's the first concept we want to talk about in our different bases. The second concept we want to talk about has to do with the value of the columns. And since we have our base 6 up here, let's start with that one. The value of the first column, the units, is always 1. Because each piece in that column is a single unit worth 1 whatever. Okay? The value here depends upon the base. In this case, each unit is worth 6. Okay? And in our base 6, in this case, each unit is worth 36. Or 6 times 6. So that will get you, understanding the value of it, will help you to figure out how many little blocks there would be there in that whole thing. Right? So, to convert this, I'm going to take how many blocks I have, 1, times its value, 36. And then I'm going to add the next column. I have 3 of them, and each one is worth 6. Plus the next column, I have 4 of them, and each one is worth 1. So my total value, or my total number of blocks that I have there, is 36 plus 18 plus 4, which is 22, 52, 58. Hopefully I added that right. Right? So the value of them has nothing to do with where they are. It just has to do with how many little blocks would be represented by this number. Okay? Let's go back to base 7 quickly and do one of those to make sure that we understand the concept. Because once you understand the concept, nothing changes except the value in the column. Let's go to base 7. And on this manipulative, I can very easily change bases by just choosing a different base. And let's illustrate our 2, 4, 6 base 7, which we had at the beginning. So that means I need 2 flats. Let me get them out again. Means I need 4 longs. And it means I need 6 units. Okay? All right, and so what now? The question we're trying to figure out is how many little blocks are up there? Well, we could sit and count them all, but that might not be the most efficient way to do it. So let's use our principle. Again, this column is always worth 1. In base 7, what would this column be worth? However many cubes there are in each stick, which, because it's base 7, is there are 7 in each stick. What's the value here? There's 7 columns of 7 sticks, or 49 little individual squares in each flat. Okay. How do I figure out how many total squares I have up here? I take the number of pieces, 2, times its value, 49, plus the total number of pieces, times its value, 7, plus the total number of pieces, 6, times its value, 1. So I get 98 plus 28 plus 6, which is going to be 132. Okay? This value just tells me how many little individual squares are represented up there. So those are the two concepts you'll need to understand to work with different bases.